Assalamu alaikum students. Today we will be start the chapter kinematics, chapter number 2, class 9th. So the chapter is about kinematics. Now let's start that words we will be study in this chapter. So first of all we will be study about rest and motion of a particles. A particle in a rest position or is in motion. So let's see that what is a position of rest and what is a motion. Therefore a certain definition of rest and motion here, and according to definition we say that a body is said to be at rest if it does not change its position, if it does not change its position with respect to its surrounding. So according to surrounding, if a body doesn't change its position, so the body will be in the state of rest. In other words, or in other way, surrounding are the place in its neighborhood where various objects are present. Similarly, a body is said to be in motion if it changes its position with respect to its surrounding. So the state of rest or motion is retrieved relatively. For example, a passenger is sitting in a moving in a bus and is at rest because he or she is not changing his position, her position with respect to other passengers or objects in the bus. But to an observers outside the bus, the passengers and the objects inside the bus are in motion. So that's the point, that how the surrounding how the surrounding relate to the object, to the person which is in rest or in motion. So now we move towards the type of motion. Let's see types of motion. So if we observe carefully, we will find everything in the universe is in motion. We are sitting on chair, our chair is on earth, the earth is moving in our universe, and earth is continuously in the state of motion. So that's why we are also in motion according to other planets, according to other space crafts. So that's why everything in the universe is in motion. However, different objects move differently. Some objects moving along a straight line, some moves in a curved path, and some moves on the other ways. There are three types of motion: translatory motion, the other name for the translatory is random, linear, and circular motion. The second one is the rotatory motion, and the third one is vibratory motion. Now let's see that's what's mean by the translatory motion or linear motion. Watch how various objects are moving. Do they move along a straight line? Do they move along a circle? Do car moving in a straight line has translatory motion? Similarly, an aeroplane moving in a straight is in translatory motion. So in translation or in translational motion, a body moves along a straight path without any rotation. The line may be a straight or curved path. So this type of motion is known as translatory or translational motion. So the explanation of translation motion is to be, the object is shown in this figure 2.3 moves along a curved path without rotation. This is a translatory motion of the object. Rider moves in the Ferris wheel, which is shown in figure 2.4. This one 2.4. This is rotationally motion, is motion in curved path. Their motions is a circular without rotation. Translatory motion can be divided into linear motion, circular motion, and random motion. Now first of all we have to discuss the linear motion. What's the means by the linear motions? We comes across many objects which are moving in a straight line, the motion of the object such as car moving in a straight line or level road is linear in motion. Linear motion. So a straight line motion of a body is known as linear motion. It means that a body move in a line path, in a straight path. That's why the motion will be straight line motion. Aeroplane flying straight in air and object flying vertically down are also the example of the linear motion. Now the second one is the circulatory motion. So the circular motion, the stone tied at the end of the string can be made to whirl. What type of is path? It follows by the stone. The stone is shown in 2.6 figure. This figure, stone are moving in this type of rotation. Then the moves in a circular path. Then thus the motion is known as circular motion. The motion of an object in a circular path is known as circular motion. Show a train. This train is moving in a circular path. Train moving in a circular track. A bicycle or car moving along a circular track possesses circular motion. Motion of an object of earth around the sun and the motion of the moon around the earth also is the example of the circular motion. Now the next type of motion is random motion. Have you noticed that the type of motion is inserted in and insects and birds? Which type of motion the insects do? The insects move and also the birds. Their movements are irregular motion. So the disorder or irregular motion of an object is known as random motion. Thus random of motion of insects and birds is a random motion. The motion dust or smoke particles in the air is also a random motion. The Brownian motion of the gas and liquid molecules along a zigzag path such as shown in figure 2.8, this type of motion will be also an example of random motion. So now we move towards the next step, and this one is rotatory motion. So study the motion of the top. It is a spring about an axis. Particle of the spring stop moving in a circle, and thus individual particles possess a circular motion. Thus top possess circular motion. The top of the shown in figure 2.9. This one figure is 2.9. So spin about the axis, its axis passing through it, and thus it possesses a rotatory motion. An axis is a line around which a body rotates in a circular motion. The motion about which a body goes around its outside the body. The rotation motion, the line around which a body moves about, passing through the body itself. Can you spin a ball at the tip of the finger? This type. So this is also a spin motion. The spin motion of the body about its axis it's called a rotational motion. Can you point out some more difference in circular and rotatory motion? The motion of a wheel about its axis and that of a steering wheel is the example of the rotation motion. The motion of the earth around the sun is a circular motion, and the earth about the geographical axis, the movement of earth, the motion of earth around the geographical axis, that causes day and night rotation motion is rotation motion. Think of some more examples of rotation motion. So now we move next type, which is vibratory motion. Consider a baby swing is shown in figure. In this toy, this baby is swing. That's this type of motion back and forth from about its mean position. The motion of the baby repeats from one extreme to the other extreme with the spring. To and from motion for body about its mean position is known as vibratory motion. Also the motion of this pendulum is also the vibratory motion. So in figure 2.11 it means shows that the to and from motion of the pendulum of a clock about its mean position is also called a vibratory motion. We can find many examples of vibratory motions around us. Look at the children in seesaw in figure 2.12. This is also a vibratory motion. How the child move from their as they play the seesaw game? Do they possess vibratory motion, or the move the seesaw. So this is also a vibratory motion. The next topic is about scalar and vector. We will discuss this topic in the next lecture. So that's it. I hope that you will be understood well. So thanks for watching this video. Assalamu alaikum wa rahmatullah.